All right, sweet. Thanks everyone for coming out today. I had a lot of fun researching this topic. I stopped taking biology classes in grade 10 general science, so I had to do a lot of catching up to understand this topic to the degree that I felt like I needed to be able to talk about it. So hopefully I'm able to impart the important stuff, skip the non-important stuff, and just give you the important details that relate to freediving. And so, backing all the way up to 2 years ago, I started freediving, and I've got this Garmin watch on my wrist that I've had for a year or two up to that point. And that Garmin watch tells you after a run, like what your VO2 max is. And the VO2 max is a metric that measures the maximum amount of oxygen that can be taken in and used by the muscles per minute per kilogram of body weight at maximum intensity effort. So what's a maximum intensity effort? What kind of thing would you be doing? Sorry?
Like the heartbeat when
Yeah.
your race out?
Yeah, and so what would raise your heart?
Sprinting.
Sprinting. That's like the perfect example. Sprinting. What else could be a maximum effort?
Steps.
Yeah, going up the stairs. Fast. Definitely fast.
Weightlifting.
Weightlifting can also get your heart rate way up there. Finning. Awesome.
Oh,
Yeah. Sorry?
Swimming.
Swimming, yeah, definitely. And maybe cycling as well. And maybe if you're going to run a marathon and try to get like a world record, or you want to qualify for Boston, you're going to be running as fast as you can for those 2.5 hours, 3 hours. And so VO2 max is a really important metric in a lot of these like long distance aerobic activities, because you're huffing in oxygen as much as you can and expelling as much carbon dioxide as you can to fuel your body. And so if you have a high VO2 max, there are some different physiological things that are probably happening in your body. Can anyone think of one? There's no textbooks, you guys didn't study anything like this, but any ideas?
Strong heart.
Strong heart. So I'm going to say that that is a high stroke volume, which is how much blood your heart physically pumps every time it pumps. Like how many milliliters of blood get pushed out. Any other ideas?
A good CO2 tolerance.
Good CO2 tolerance? Not so much. I'll fill in the rest of the piece here because it's again there were
Effective breathing capacity. Cellular absorption.
yeah, and so I'm gonna write down hemoglobin,
Learn how your hemoglobin releases
myoglobin,
the oxygen into the working muscles. So
and what was the third one? Hemoglobin, myoglobin, mitochondrial concentration.
that's it. That's what I wanted to say.
CONC, concentration.
What's CONC? Concentration.
Concentration, just short form.
Yeah.
The next one is an increased capillary density. So you have more of the tiny blood cells that transport blood to the muscles. Capillary density is higher. And stroke volume. Yeah, you have a higher likelihood or higher percentage of slow twitch muscle fibers, which is what we use when we are running long distances, and not so much that we use during powerlifting, or if you're a basketball player jumping up and shooting a basketball. Those are your fast twitch muscle fibers. If you have a high VO2 max, it's more likely that you have higher slow twitch muscle fibers. Not super important. The other factors that affect your VO2 max, genetics, right off the bat there. Different people are born with different predispositions for a higher or low VO2 max. Your lifestyle, what you eat in a day, how many steps you get, all that jazz, and your age. The older you get, your VO2 max will decrease by about 1% per year.
Others.
So this all sounds like really good stuff, right? Well, when I first started freediving, there were conversations on the internet, because of course I researched the crap out of freediving as soon as I started getting into it. there were conversations on the internet about how having a high VO2 max is going to make you a worse freediver. What the? I thought, that's bananas. I can't believe that. That doesn't make any sense to me. And people were talking about this mythical VO2 min, which when I researched it, it's not a real performance metric. And that they were saying that if you have a high VO2 max, you're going to burn all of your oxygen sooner during a free dive, and you will not have the energy to finish a free dive. Like if you're going 40 meters or doing 100 meters in the pool. I thought that's baloney, but with my limited knowledge on the topic, I have no backing to that, and I wanted to prove to myself and hopefully to you guys that I think it is baloney. So a little foreshadowing there. One other thing about VO2 max that I think is really cool is that it is a very strong correlation with all-cause mortality. If you have a high VO2 max, your chances of dying earlier are lower from all causes. So I want to live a long, happy, healthy lifestyle, but I also love freediving. And so trying to blend those two things together, they felt like they were at odds. So that takes us into the first topic here of cellular respiration. When you breathe in oxygen, that oxygen is burned to create energy during your aerobic energy production. The first step, glycolysis, creates, cellular respiration is all built around ATP. Let's just call it the energy molecule. The more of them you have, being generated by your body or in reserves, the more effort you're able to put out. Okay? High amounts of ATP is good, allows you to do athletic things, like free diving or jumping or running 100 meters. And so when we're in the aerobic energy production, which is like what we're all doing right now, we're breathing in oxygen, and we're letting it out, or we're letting out carbon dioxide. We are taking sugar molecules and burning it in the first step of glycolysis. And this gives us, 2 ATP molecules. Not very much. Then the next step, the Krebs cycle, is the part that the details that I'm skipping over, just part 2, gives us a couple more ATP. And it requires oxygen to function. And then it gets to the third step, the electron transport chain, ETC. That's all you need to know. This gives you about 34 ATP. And so that is, and it requires oxygen. And so that is a lot of energy. The issue with aerobic energy is it requires oxygen and time. This is a very slow process. So when you start sprinting 100 meters, you're not able to create this ATP anymore. You burn through it really fast. Because your body, right now, it has reserves. If you stood up, you started running, you would burn through that available energy that you have in your body really quickly, and then you would move into your anaerobic energy production. So we have some different steps there. The first one is burning your ATP. All of your ATP reserves in your body. That takes about 2 seconds. And so if you're doing something like shot put, taking the ball, tossing it like you're in the Olympics or doing your high jump, you're kind of staying in this step 1 because it's a very, very short maximal effort. The second step, it's called the phosphocreatine, PC. Title's not that important. Uses a different process, and that gives you a lot of extra ATP for 8 to 10 seconds. So if you're running 100 meters, you burn through that ATP for 2 seconds, and then Usain Bolt doing 9-second 100 meters in the Olympics, he's burning through the rest of his phosphocreatine for that 8 to 10 seconds. Then he's done, and that's it. But if you're one of those crazy people that runs the 800 meter or the 400 meter race, you then enter the lactate production. And when you enter the lactate production, you're probably going to get 1 to 2 minutes of additional energy production, but it's at the cost of, wait, what happens when, is it pain, fatigue, tiredness, that burning sensation. If you're free diving, it makes you want to breathe. So that gives us about 1 to 2 more minutes of energy production before it feels like we just have to give up. So that's how we generate energy within the body at a very, very basic level. We take sugars and we add oxygen when we're doing aerobic energy production to create lots and lots of ATP very slowly. But if we enter a low oxygen environment, like we are running really fast or we're holding our breath, we burn through our ATP, then we use this other process of phosphocreatine to create a little bit more ATP, and then we finally create ATP through lactate acid buildup in our bodies, which is very fast and productive, but at that cost of the lactic acid building up inside of our bodies. So, just a quick little demonstration. So if you're running a slow marathon, which system are we going to be in? Aerobic the whole time, potentially. If you run up a hill or something, you might switch into the anaerobic energy production, but generally kind of aerobic if you're going really slow. 100-meter sprint, like I said. Hey, we are just in that kind of step 1 and step 2 of the anaerobic energy production. We burn through all that ATP, and then we're into the phosphocreatine section. 400-meter race, all 3, and then we feel like garbage after. So, bringing this back to VO2 max, we have what's called the onset blood lactate accumulation. At what point during your effort does that lactate start to build up? So we've got blood lactate concentration on the left, running speed on the bottom. So we're running faster and faster and faster. And we get to the point, lactate starts to build up. Then, the lactate concentration builds up and we hit our threshold. Oh, man, I feel like garbage. I want to stop. I can't run anymore. What happens if you have a good VO2 max? You're running faster and faster and faster and faster. Oh, I'm better than I was 6 months ago. I ran further, or I ran faster. And as that blood lactate starts to increase, my threshold is higher. I can withstand more lactic acid in my body before I feel like I have to give up. If an untrained person's, this point, the OBLA, onset blood lactate accumulation, starts to build up, occurs at 50% of their VO2 max, a trained person will experience that at 75%. It's a really big difference. If you sit at a desk all day and don't exercise very frequently or very intensely, if you have to exercise really hard, it's going to happen. You're going to feel like garbage pretty soon. But you train your body and you do some moderate exercise, that point comes later. And so, what happens after you finish exercising? Your post-exercise oxygen consumption. In the first 1 to 2 minutes, we rebuild our ATP and that phosphocreatine process. So if you do a 10-second sprint, wait a few minutes, you can do another 10-second sprint. You rebuild those energy stores pretty quickly. But if you got into that lactate buildup phase, lactate metabolism, your body requires oxygen to get rid of that lactate. And that can take a long time, 1 or 2 hours of breathing and relaxing before all of that lactate is flushed out. Sorry, this first 1 to 2 minutes, you also fix your myoglobin levels. Go back to normal. So like the oxygen that's stored in your muscles will return, and this lactate metabolism will actually transform that lactate acid in your body back into carbon dioxide, water, sugar, glucose, and protein. I find that really amazing. The lactic acid that is in your body was produced, and then as you breathe oxygen, it turns back into other components that are useful for your body: water, carbon dioxide, sugars, and proteins. So, let's say during a breath hold, we have time and like energy production. Breathe in, we hold our breath, we start producing aerobic energy, but then that will start to decrease and reach some sort of minimum. And then our anaerobic system will start low and then eventually start to take over. So because of the lactic acid, you want as little of the anaerobic system as possible and more of the aerobic system to like last longer. Unfortunately, I couldn't find any research that actually talks about breath hold divers and energy production. This part is more of like a inference, like what we've all dived and we feel the lactate building up, right? It kind of sucks. It feels awful. Yeah. Okay. Okay. So then, kind of the last info dump that I'll do is a lot of recent research that's been done by this guy, Thomas Kjeld, in Denmark. He found some really interesting things related to this topic that I just want to mention. Number 1, freedivers have a lower mitochondrial oxygen consumption, which means that their aerobic energy production is smoother and lasts longer. So these are all adaptations that freedivers start to build up the more that they do freediving, that this guy found. Freedivers have a higher concentration of enzymes for their anaerobic energy production, making that part more efficient. Lactate, and if you combine lactic acid with a freediver's blood, it increases how much oxygen is being unloaded from the blood, like it's sucking it back out, which is kind of similar to the topic that we learned in Wave 2. With, I forgot. Yeah. No, it's...
carbon dioxide, helping to offload oxygen.
Yeah.
More effect.
Bohr effect, yes. Like a similar thing to that. Next, glucose increases during aerobic exercise for freedivers, which suggests that the lactate metabolism that I was talking about, that really amazing, I erased it. The lactate metabolism is more efficient and occurring during inside of a freediver's body. And freedivers can have a very, very low oxygen saturation amount of, we're all at about 95%, 99%, like we learned in Wave 1, but a freediver can tolerate up to like 36%, which is crazy. And so, in summary, all of these things that are kind of related to cellular respiration and making freedivers more efficient underwater than they otherwise would be the more that we do it. These are all things that are found in aquatic mammals, the cetaceans. We all came from the same ancestors. We share so much, and it's amazing what researchers are currently finding about how we are able to create energy and use energy in the body during breath hold or free dive. So, what does this all mean? Unfortunately, I'm inferring at this part, and I'm very interested to hear anyone else's opinions or thoughts on these things, but it's kind of the conclusions that I've found based on all this research about VO2 max, energy production, how does a freediver's body work, all this stuff. Our body has aerobic and anaerobic energy productions with different speeds and quantity of energy produced. The VO2 max is based on so many different factors that are most importantly physiological, like I've listed here, the stroke volume, hemoglobin, myoglobin, mitochondrial concentrations. That all indicate that a person with a high VO2 max is able to withstand, or is able to perform maximally at greater efforts because of the training that they've received. The high VO2 max means that our blood lactate accumulation starts later, and we're able to tolerate more of it. And it can take a really long time to oxidize or offload that lactic acid once it builds up. And if that takes a long time, what happens if you dive really intensely in the middle of a session and you feel the huge lactate build up in the middle of a freediving session? Any ideas what happens?
It's going to take you the rest of the session to recover.
Absolutely.
Yeah.
And so like, I kind of noticed it during the competition. I had a cramp. That cramp didn't go away for a very long time.
Yeah.
Right? So understanding this stuff has really practical impacts on a freediving session, especially if you're a coach or if you're training. Do you push at the beginning? Do you push in the middle? Do you push at the end? Do you just try to avoid lactic acid buildup altogether? Do you train in the gym 3 times a week so that you don't experience lactic acid buildup during one of your typical freediving sessions? Do you save that part only for the maximum intents? And breath hold divers show a ridiculously cool number of powerful adaptations to lactic acid buildup inside the body, and how it's so similar to all the other diving mammals that we've studied: whales, dolphins, and all the other cetaceans. So, my conclusion from all of this: you should exercise. You should go for runs. You should lift some weights. You should do stuff that works your body on land, moderate to intensely, so that you are stronger, more capable. Your cells are able to oxygenate. They're able to use the oxygen that is in your lungs and in your blood to create that energy. Why would you want a low VO2 max? Why would you not want your body to take the oxygen and use it for that aerobic energy production for as long as possible? High VO2 max to me just means that the oxygen is being sucked out of the lungs and of the blood, and it's put into the muscles where I want it to work, being sucked into the brain where I want it to be doing its job. It's not a very exciting conclusion, but this is a question that I've had for so long, and I got so upset that I couldn't figure out what the answer was, because some people had some answers and some people had others. Going back and understanding all the biomechanical processes behind it, and man, if you have any questions, please ask. We have a zoologist in the room, so he might be able to describe better. Don't listen to everything you hear on the internet. Exercise, live a long, healthy life, and the more freediving you do, the more adaptations you're going to have, and the better you're going to be in the water. Unfortunately, it's simple. And I think that having a high VO2 max, up until the point maybe that you're trying to break world records, can only serve you in a sport. And until then, just exercise, and you get to that point, get a coach that knows, and a scientist that knows what they're doing. Yeah, so that's the presentation.
Good job, Jim. Jake, the 36%, what study is that and what conditions?
Thomas Kjeld 2026 paper that came out, I think, just a couple months ago.
Really?
Yeah, so unfortunately, when I was reading the summary of findings in that, I don't know. I had to do a lot of Googling just to be able to summarize them into this amount. So I'd love to just crack that open with you and understand it better.
Well, was it like statics or?
Yeah, I don't think anything here was dynamic or depth related. It was all static, and even for the taking lactic acid and adding it to freediver blood, it took a freediver not doing a breath hold. It's called remote ischemic conditioning, so they tied a strap around the arm to stop the blood flow, and once the blood reached whatever point they wanted, they took it out, put it somewhere else, added lactic acid to it, and then they got the oxygen unloading from that blood. It was really, really cool. Or increased oxygen unloading from the blood. So yeah, we can crack it open.
Is that?
And confirm exactly the conditions that it was in. But this study was also, these studies were also done with actual freedivers, and trying to find an alternative point of view to what I was thinking with this VO2 Max stuff. I found a research paper that said if you're a freediver, you have a worse breath hold, but the average breath hold time in that study was 36 seconds, and the VO2 Max was like 38 plus or minus 5, which is a pretty low number for a VO2 Max. So I was like, oh, this study, it's baloney. It doesn't matter.
Yeah.
You know, it's like not realistic conditions for us.
Can you see some pictures?
Please, yeah.
Because I don't have my glasses.
Which slide would you like?
Oh, right there. Because I don't have my glasses.
That one with the oxygen saturation, is that just maintaining consciousness, like at 35?
Yeah, it was specifically talking about it was specific. It was the oxygen concentration down to 36% without signs of cardiac ischemia, which is a lack of oxygenated blood to the heart. So yeah, like they were still, the body was still functioning.
Yeah,
I think
yeah.
is the reading between the lines there.
Still alive.
Yeah. Did not mention consciousness.
Yeah.
Maybe it did in the actual paper. But
Yeah, no. I mean, maybe it was saying that if other untrained people went down to that low, they would have like a heart attack or something.
yeah. Yeah.
Are there any exercises that are better to improve your VO2 max than others? Like, or is it just going to the gym, living a healthy lifestyle?
Yeah,
Are there
so
any specific exercise I can do to improve my VO2 max?
yeah, I should have actually said instead of going to the gym, I should have said going for long, slow runs and sometimes doing high intensity short runs. So if I went out and I wanted to hit like a 5 kilometer run personal best, I would be hitting that VO2 max point during that run. I'd be hitting my physical limits. Or even a shorter distance, like 2 kilometers. But you just kind of go all out and try to hit it. That's exercising your VO2 max. But then running long, slow runs is building that base endurance. Yeah.
So you train aerobically,
Yes. Yeah.
and you
Yeah.
just leave the anaerobic performance.
No, I think that training anaerobically sometimes is important for human health. Like
Yeah.
For overall
But
conditioning.
for VO2 max, like the most effective. This wasn't in your presentation, so it doesn't matter if you did.
fair enough, yeah.
Yeah.
But like if you're going to, like I've done this before, I wanted to increase my half marathon time.
Yeah.
I ran some very long, slow runs,
Yeah.
and other times I ran very short, fast runs.
Yeah.
Now when it comes to race day, you're running a long distance as fast as possible.
Yeah.
So you're kind of taking the two different training methods and slamming them together.
Yeah.
Same thing that I do in the pool for freediving. I start my session with sprints, 25 meters, short distance, high intensity, not very long, 8 to 10 minutes total, and then I switch into volume. 50-meter lengths as slow as possible with good recoveries. So then I'm training lactic acid buildup, and I'm training slow calm distance swim, good technique and everything. That for me has gotten me to 100 meters the other day. So
So that would be building up lactate straight away to then have the whole session with lactate get.
as I was saying that,
Yeah.
great point.
Yeah.
I might want to switch how I do my training and do long, slow swims at the beginning of the session and then finish with 8 minutes of intense work.
Yeah.
That's, yeah, I'm going to try that out next time I'm
Yeah.
in Ottawa in the pool. Yeah, great observation.
Unless you have time enough for recovery, like an hour between the sprints and the 50s.
Yeah, and yeah, so
to
this,
get the lactate to transform into.
yeah, and so like I said with like if you ran a 100-meter sprint, you're not quite entering lactic acid buildup. And so if you take a couple minutes break and then do another 100-meter sprint, you should be not building up too much lactic acid. But with freediving, as we've all experienced, you're suddenly in an extremely low oxygen environment. You only have your full lungs worth for that effort. I feel that lactic acid building up almost immediately when I'm doing sprinting underwater. So, yeah. Whereas, like, if I started a soccer training, beginning of the day, I do some sprints, I might still have the energy to finish off the day because I didn't quite get into lactic acid buildup. But with freediving, great point, I might be getting into that lactic acid and possibly compromising the rest of my session because I haven't offloaded that lactic acid completely. But freedivers are able to offload lactic acid better than other people, so that's pretty cool. Because of some crazy adaptations that we start to build the more we do this.
Yeah. Just half an hour break. And then
Yeah.
we're good.
I mean, I take like a 4-minute break, 5-minute break, and then I start doing 50s.
Yeah.
Really slow.
Yeah.
And I feel fine, but great observation. I'm going to switch it and see how I do.
When we do pool training, we do the other way. We'll do a long, and then have a 5 minutes and then sprints. Always finish with sprints.
Yeah, and that makes sense.
And then CO2, a hypercapnic swim.
Yeah.
It's not fun.
So yeah. I'm gonna be a better freediver now just because I did this presentation and got that feedback. Yeah. Any other questions or thoughts or any confusion that I can maybe clear up?
I think it was a very difficult topic, and I thank you very much.
Yeah.
Oh, thank you.
Thank you all for, yeah, because I study at that school, but yeah, it's a difficult topic. And thank you because it's a good reason.
Thank you very much. And yeah, for all of us, I hope that this is just like a leaping off point to better understanding or your own research. I watched a dozen free YouTube videos to understand all this content from people that are teaching medicine students and second-year biology students and stuff to increase my grasp of all this. And then like a sports science guy as well, which I have a playlist for actually if anybody wants to watch it on YouTube. You know where to find me. Sorry, anything else? No, okay. You guys know where to find me. Thank you very much for your attention. I really appreciate it. That was a lot of fun.
Thank you.
Professor J. But I went.
Have any of